Hello there, we are Group 6 and we are going to tackle question 8 of discussing how AI has been used in gaming and robotics. We have done a documentation of this particular question 8, and we have used related images to explain the same. We have also set our own question which is question 2 of the assignment, and we will talk about uninformed search.
So, question 1, artificial intelligence has become increasingly prevalent in game playing and robotics. In game playing, AI has been used to create more challenging opponents, which in robotics is used to create robots that can perform complex tasks autonomously.
For AI in game playing is used to create intelligent opponents that can challenge human players. AI game playing agents use a variety of techniques such as decision trees, reinforcement learning, Monte Carlo's method, and deep learning to learn from the experience and make strategic decisions in real time. For example, in the game of chess, AI game playing agents use decision trees to evaluate the board state and determine the best move.
As you can see in the diagram below, there is a person playing with a machine in the game of chess. This shows that an AI machine can be used as an opponent to play various games. So, for example, if you want to have a multiplayer game, you do not have an opponent, a human being opponent, you can use a machine as an opponent.
These are some of the ways in which AI has been used in gaming. We have our first one that we're going to discuss is pathfinding. One of the most common use of AI in gaming is pathfinding. This involves the AI-controlled NPCs finding the most optimum path to reach a particular location while avoiding obstacles such as walls, cliffs, or other NPCs. Pathfinding algorithms allows NPCs to move around the game while in a realistic and efficient manner. Like as we can see from this image here, let's say for example a player is moving from this end, so he can navigate in through this image, avoiding hitting the obstacles or the walls here, and navigate all through until it comes to this exit point here.
So another way is through behavior trees. Behavior trees are used to model the behavior of AI-controlled NPCs. A behavior tree is a decision-making system that determines what action an NPC should take based on a set of conditions. For example, an NPC is a stealth game. In a stealth game, might use a behavior tree to decide whether to sneak up on a player or attack them head-on, because they will have looked at the behavior of a human being as he makes decisions through the game.
We also have procedural generation. Procedural generation is the use of algorithm to generate game content such as level, quest, or items. AI is used to create procedural generation system that can generate game content that is unique and interesting. So it is often used in games that have large game world and require a lot of content.
Different games have different levels. So in a game, there can be missions whereby people try to achieve a certain score in order to move to a certain level. So they play in order to achieve a certain goal and move to another level, which also have another quest.
The fourth aspect is dynamic difficulty adjustment, and in dynamic difficulty adjustment is the use of AI to adjust the difficulty of a game based on the player's skill level. AI can monitor the player's performance and adjust the game difficulty in real time to provide a more challenging experience for skilled players or a more relaxed experience for casual players, as illustrated in the diagram below.
Another way is through adversarial learning, and this learning is a machine learning technique that is used to train AI-controlled NPCs to behave like human players. As we looked at the example of a chess game, we have seen that the opponent will also know how a human being thinks. So AI is trained by playing against human playing and learning from their strategies and behaviors. This will result to an NPC that are more challenging and unpredictable, providing more engaging experience for the player. Looking at the diagram, we have the training set to the training model, then the tests, and if it will be a wrong test, then there will be a wrong output. So AI game playing agents can also adapt their strategies based on the behavior of human players, and they will learn from the patterns and strategies of human players and use the information to improve their game.
Now, our part 2 of the question is AI in robots, where AI is used in robotics to create robots that can perform complex tasks autonomously. Robotics applications of AI include autonomous navigation, object recognition, speech recognition, and natural language processing. Now we will discuss these one by one.
For example, autonomous vehicles use AI to navigate roads and make decisions in real time. They use sensors such as cameras, LiDAR, and radar to perceive the environments, and machine learning algorithms to analyze this data, make decisions about steering, acceleration, braking.
Yes, as you can see in the diagram, there is a diagram that shows a vehicle that can detect anything around it as obstacles. It can also use the sensors to show its direction. It can help it at least in navigating itself.
The image also, as you can see from this image, this vehicle, it's sensing a vehicle ahead of it, sensing a person and a hole in front, so the driver can be notified of the obstacles ahead.
So we have several ways in which AI is used in robotics. We have perception. AI is used to enable robots to perceive their environment and understand what is happening around them. This involves using sensors such as cameras, LiDAR, radar, and to capture data, and then using AI algorithms to process and interpret the data. As shown below, we have a diagram of a person, and it's a robot, or is able to identify what is the object as shown below.
The second aspect is decision making. AI is used to enable robots make decisions based on their perception. This involves using machine learning algorithms to train the robot to recognize patterns and make predictions about what actions it should take in response to a given situation. AI algorithms can be used to plan and execute actions and to adjust the robot's behavior based on feedback from its sensors, as illustrated in the image below.
Yeah, as you can see, most of the intelligent machines can be used. They can help in decision making. For example, if you have a certain problem, you can ask an AI machine, since it acquires knowledge. When people interact with it, it acquires knowledge, so thus it knows what a human thinks and what a human requires for one to survive.
Another is control. AI is used to enable robots to control their actions and movements. This involves using algorithms to plan and execute actions and to adjust the robot's behavior based on feedback from its sensors. AI algorithms can be used to optimize the robot's movement, making them more efficient and precise. As in the diagram below, you can get to see a robot that is looking at how to control the machine there.
Learning. AI is used to enable robots to learn from the experience and improve their performance over time. This involves using algorithms such as reinforcement learning and deep learning to train the robots to perform tasks more efficiently and effectively. AI algorithms can be used to adjust the robot's behavior based on feedback from its sensors to optimize its performance based on its previous experience. For example, as you can see on this image here, you can see the robot is investigating something on the objects that it's holding, it's obtaining, and is learning something from the objects there. AI robotics has many practical applications in industries such as manufacturing, healthcare, and transportation. For example, AI robots can be used to perform repetitive or dangerous tasks in manufacturing plants, assist with surgeries in hospitals, and transport goods in warehouses. With continued advancement in AI and robotics, the potential for AI robotics to revolutionize these industries and many more is enormous.
As you can see in a diagram, in a hospital, it can be used to
enhance services to patients using artificial intelligence, thus reducing repetitive tasks that should have been done by humans.
Also in the image you can see there is a robot which is collecting some information from the patient there, the mother who is holding a child, so it's collecting some data, maybe providing the service.
In robotics, AI is also used to recognize and manipulate objects. Robots use machine learning algorithms to recognize objects and determine their properties such as size, shape, and texture. This information is used to manipulate the objects in a precise and controlled manner, as illustrated in the image below.
Another application of AI in robotics is speech recognition and natural language processing. Robots can use natural language processing algorithm to understand and respond to spoken commands, making it easier for humans to interact with them. Below is someone trying to interact and the robot is trying to get things.
Again, there is also another example of speech recognition like the AI Alexa, where you can command it and it does what it executes the command that you have given.
For the second assignment that we have was to explain the following aspects of informed search, of an uninformed search, such as depth-first search, depth-limited search, uniform cost search, breadth-first search, and iterative deepening search.
So uninformed search refers to a class of search algorithms that do not use any domain-specific knowledge to guide the search process. Instead, they rely on a systematic exploration of the search space, often starting from an initial and state, searching until a goal state is found.
The depth-first search is an informed search algorithm that explores the search space by traversing each branch of the search tree as deeply as possible before backtracking. This means that the DFS can quickly reach the bottom of a path before exploring other paths, making it memory efficient but potentially slow if the goal state is far from the starting state.
Again, the depth limit search DLS is modification of DFS that limits the depth of the search tree to a certain level. This can be used when the search space is very large or infinite, and depth-first search will potentially continue infinitely.
Uniform cost search UCS is an uniform search algorithm that takes into account the cost of each path in the search space. It starts from the initial state and explores the neighboring state with the lowest cost first. This means that UCS is able to find the optimal path to the goal state in terms of cost, but can be slow if the cost of each step is large.
We also have BFS, which is breadth first search, is a uniformed search algorithm that systematically explores all the neighbors' state of the initial state before moving to the next level of neighbors. This means that BFS is able to find the shortest path to the goal state in terms of the number of steps, but can be memory intensive since it needs to store all the visited states in the memory.
Iterative deepening search, which is IDS, is a combination of DFS and DLS that systematically increases the depth limit of the search until a goal set is found. This approach combines the benefits of both DFS and BFS, allowing for efficient memory usage and the ability to find the optimal path to the goal state in terms of both cost and number of steps.
And those were the 2 assignments that we have done as group 6, and that is the final part of it. Thank you.
Now this marks the end of our discussion. Thank you.
Thank you.
Thank you.